All right, so summation or sigma notation is a concise way of describing the sum of a sequence of related numbers. So we've got some weird symbols here and some strange vocabulary, but hopefully this all makes sense in a second. Um, okay, so what are we doing here? Um, so the sigma sign, this is a sigma, it's a Greek letter that that gives you the S sound. Um, Indicates that we're doing a sum here, and we're summing a sequence, um, which is so if I've got a series of numbers, a bunch of numbers in a row, or in order, and they're related by some kind of rule, like you take the first element, you add two, and then to get to the next element, you add two again. Um, so if I want to sum up a certain set of those numbers, like maybe the second number through the seventh number, I would indicate that with sigma notation. So I is the index of summation, meaning um, what 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 terms I'm summing. N would be the lower bound, n would be the upper bound. So if I want to say I want to sum up the third element through the seventh element, I would say I equals 3, and I would put a 7 on the top. So sum up the third through the seventh terms that follow this rule. All right, so let's just do a concrete example. The example would be much simpler than all this. Let's do our sigma. So we're gonna this is gonna be a big one. Okay. So let's say x equals 2 through 8 of the sequence that's defined by the rule x squared. So that would be equal to, so first I would do 2 squared, okay, and then the next number up would be 3. I go by integers, right? So I'm going to 3, 4, 5, 6, 7, 8. So 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared plus 8 squared. Okay? So what this is saying is do this sum. Okay, so hopefully you can see the advantage of sigma notation. This thing is tiny, right? Very compact. I mean, can you imagine writing out this one. Switch colors here. Um, you know, I equals 1 to 1,000 of the rule will be 2i minus I squared. Um, you know, so I'm taking the first term that follows this rule, then adding it to the second term. So 2 times 1 minus 1 squared, 2 times 2 minus 2 squared, 2 times 3 minus 3 squared, 2 times 4 minus 4 squared, etc., all the way up through 2 times 1,000 minus 1,000 squared, and then taking all those things and adding them all up together. I could not write that on this screen. I couldn't write that on a lot of screens, actually. So this is very compact. It's describing a process in a way, it's much easier to write than actually writing it out all of it out by hand. So that's what sigma notation is. That's what the pieces are, and that's what it's used for.